Which of the following alkenes are Z isomers? So E and Z are the terms that we use to describe the stereochemistry of alkenes that are not symmetrical. So when you have a Z alkene, what that means is that you've got the two highest priority groups on the same side of the alkene. So that would be a Z alkene. The E alkene would be the opposite of that, when you have the two high priority groups on opposite sides of the alkene. And so when we're deciding on the side of the alkene, we're always bisecting the molecule right through that pi bond. Right, so right through that pi bond. So it's pretty obvious with these that when you get to a zigzag structure, like kind of a bond line structure of an alkene, remember that even if you have like the zigzag of an alkene, you're going to go right through the center of it. Okay, so how do we decide these priorities? So the highest priority groups go to the atoms with the highest atomic number. So highest priority is equal to the highest atomic number. And so what we're going to do is you look at each carbon atom of the alkene individually. So if we're looking at this first one, we're going to look at this first carbon atom. And we're going to look at the two things that are bound to that. So we have a carbon, and so we go directly to the next atom, and we have a bromine. And since the bromine has the higher atomic number, that would be priority 1, and the carbon group on the other side would be priority 2. And then we want to consider the other carbon atom of the alkene, and it has a bond to a hydrogen here, and a bond to a carbon on the bottom. So carbon has a higher atomic number than hydrogen, so that is a highest priority, and the hydrogen is the second highest priority. So these are on the same side of the alkene. So this first one is a Z isomer. Okay, so we found at least one. We'll go through and check these other two structures as well. So if we're looking at this center alkene, we're first looking at this first carbon atom. We see a chlorine on one side and a carbon on the other side, and chlorine has the higher atomic number. So that is the higher priority group. Carbon is the second highest priority group. And so then we go on to the next side. And we see we have a bond, so this is the carbon we're looking at, and it has a bond to a carbon and a bond to another carbon. So looking at that first atom has not differentiated, so we need to move farther along these carbon chains. So we do that by saying, well, what is that atom, that carbon that we were looking at, what is it bound to? And so remember that carbon always makes 4 bonds. So this carbon here has a bond to 1 carbon and 3 hydrogens. And so I always list these 4 bonds in order of decreasing atomic number so that when I compare, I will see the difference very easily. So this carbon on the top has a bond to carbon, another bond to carbon, so 2 bonds to carbon, and then 2 bonds to hydrogen. And so here we found the point of difference. We compare carbon, 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 hydrogen. There's our point of difference. So that means that this top group is going to be the higher priority group and the bottom is the lower. And so the high priority groups are on opposite sides. So this alkene is an E alkene. And then if we go to the last one, I think this one's going to be a pretty fast comparison. We have hydrogens on either side. We know that hydrogen, there's nothing with a lower atomic number. So hydrogen's always going to be 2. So whatever's on the other side is going to be 1. So this last alkene is also an E alkene. So we only have one structure that is a Z alkene. So that means our answer here is A.